Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the binary tree pre-order traversal problem. Apologies for the whisper voice, I'm recording this at 8 o'clock in the morning. Don't want to wake the neighbors. Anyway, given the root of a binary tree, return the pre-order traversal of its nodes' values. So given this tree here, 1, 2, 3, we want to do a pre-order traversal. So that means we're going to look at some node, then deal with the left, and then deal with the right. So we're going to look at the 1. So we write down 1. Then we look at the left, and there's nothing to do. Then we look at the right. So we're looking at the right. We're going to deal with the node itself. That's at 2. So we write down 2. And then we're going to deal with the left, and then we're going to deal with the right. So the left, we're going to look at the node. We're going to write down the 3. We're going to deal with the left, there's nothing to do. We're going to deal with the right, there's nothing to do. And back up here, we're going to deal with the right, there's nothing to do. So we're done. 1, 2, 3. So traversals almost always take the same shape. If root is none, return. Then we want to do some processing on the root. And we want to do a pre-order traversal on the left. And then we want to do a pre-order traversal on the right. If I was to move these around, say I was to move this line down here, this is no longer a pre-order traversal, it's what we call an in-order traversal. Because we're going to deal with the left thing, then the node itself, then the right thing. And then we've got the final case, which puts the action on the root at the end. What that's going to do is it's going to say, well, now it's a post-order traversal. I'm going to deal with the left, then I'm going to deal with the right, then I'm going to deal with the node itself. And they always take this kind of shape. Now here we don't have an F, we'd need to deal with that slightly separately. So in fact, this entire thing here probably need to be moved to a separate function, just because it's a bit of a pain in Python to handle the actual problem that they want us to do. The other thing it notes down here, the recursive solution is trivial. Could you do it iteratively? The recursive solution is pretty trivial, let's be honest. It's a very important skill to know, but it's not a particularly difficult thing to code up. So how can we do this iteratively? So what we're going to do is we're basically going to do exactly the same solution, but we're going to do it with a explicit stack. So the recursive version relies on the call stack, how functions are handled inside pretty much any programming language. But what we can do is we can maintain that stack explicitly. So let's have a stack. And it's going to start with the root on it. While there's things on the stack, node is stack.pop, if node is none, pass. Then we want to do our processing. And then we want to do stack.append node.right, stack.append node.left. Now, this is back to front, seemingly. Why is this back to front? Well, the problem is when we put things on the stack, we're going to put them effectively backwards. I want to deal with the left thing first, and then deal with the right thing. And to do that, I need to push the right thing on first, so that when I put the left thing on top of it, again, stacks are like piles of pancakes. If I put one pancake on and then a second pancake on, I'm going to eat that second pancake before I eat that first pancake, unless I want to make a horrible mess. So that's what we do here. We have to put the right on first, so I actually deal with the left first. Now to actually answer this problem, I need to create a list of nodes. So processing the, in fact, this is more vals, isn't it? So when I process the node, what I need to do is I need to do vals.append node.val. So if we look at this one here, we're going to start with the root, which is this guy here. We're going to take the root off the stack by popping it. We're going to process its value, the 1. The 1 is going to get put on our vals list. Then we're going to put the right side on. That's all this here. And then we're going to put the left side on. And that's the stuff over here. Now the left is a none. So when we get them to pop it off again, the node is none. So we're going to, not pass, we're going to continue. I'm going to continue back around again. Now we're going to process the right-hand side. So we're going to take off this 2, 3 business. We're going to process the 2. That's this here. And then we're going to put the right side on, which is none. And then we're going to put the left side on, which is 3. So we're going to take the 3 off. We're going to process its value and put it onto our list. That's a 3. With now vals is now 1, 2, 3. We're going to put we're going to put the right side on, which is none. We're going to put the left side on, which is none. So both of those come off. None, none. We don't do anything. And then we're back up here to deal with the 2's right-hand side. That's a none, so nothing happens. Let's run it. Excellent. All looks good. Let's submit it. Excellent. So we're not doing super great on time. We're not doing terribly on time. One thing we could do to make this a little more efficient, or possibly, I'm conjecturing wildly, as the golden rule with testing, with optimizing speed is test, 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 test. Just because you think something will be more efficient doesn't mean it will be. But my conjecture is if we actually checked whether these things were none or not before we put them on the stack, that would be more efficient because it's one check, a none check, which in Python is generally very efficient, versus 2 stack manipulations that don't actually do anything, an append and a pop. And in particular, append can be quite expensive. Pop can be, but it's usually not. Because append might require you to entirely reallocate the list in Python. That can be very expensive. Anyway, that's all wildly unnecessary optimizations for this particular problem. This is an easy problem. This is teaching you a very valuable skill. Strongly recommend you learn your pre-order, in-order, and post-order traversals because they are just bread and butter algorithms, and they translate well to any language. Obviously, in Python, we're probably going to favor a solution like this just because recursion isn't great in Python. Whereas if you were to go to a much more functional language like Haskell, you would almost certainly reach for that recursive solution. It will knock the socks off it. You might have to be a bit clever about how you build the list. That's a great question for you to think about. How would you build a list efficiently for some of these traversals? But anyway, that's it. That's it from me this week. Today, not this week, just today. I'll see you the rest of this week as well. Do remember to like, comment, subscribe, all of that good stuff. I shouldn't record at 6 o'clock in the morning. I will see you next time. Bye.